hello, everybody who's decided to tune in to either Sacred Space Astronomy, the blog for the Vatican Observatory, or my YouTube channel, the Vatican Observatory Fanboy. And today I'm going to be doing my second conversation. Last time, if you remember, if you saw, I did a conversation with Dr. Gann from Steubenville University about artificial intelligence, both his use of it, he's actually a programmer of it, but just some of the things that people misunderstand about AI, what it is, what it isn't. So feel free to check that out. And that conversation went so well. I had this feeling of, I want to start to do a little bit more of these. And one of the first people I thought of was the person we have today, Dr. Brenda Frye from University of Arizona, and correct, also the Steward Observatory as well.
Yes, that's right.
And
Yes.
just so you all know, I got to know Brenda years ago when she would present for the Faith and Astronomy workshops. And I know I've shared this with Brenda already, but because I'm not just sharing this because I'm interviewing or talking with her, she's always one of my favorite presentations whenever she presents. Specifically, her presentations on dark energy and dark matter, and just to me there's just a fascination with it. And to be quite frank, part of that fascination, Brenda and her team gets time on the Hubble Space Telescope, and there's just kind of a whole slew of questions like, how does that happen? How does that, I presume you just don't dial up the Hubble hotline and say, oh, can I have it from 6 to 7 tonight? That there's a process to that. But also, too,
Right. Yeah.
we're in an amazing. I remember one time I asked Brother Guy, are we in a golden age of astronomy? And I loved his answer. He said to me, James, no matter, as long as we keep on looking to the skies and start asking, what is it? How did it get there? What is that? We'll always be in a golden age of astronomy. And boy, when you look at the Hubble Space Telescope, things like the Andromeda image that some amateurs collaborated on to get this, never before seen nebula, the Giant Magellan Telescope, and the Hubble as well. Boy, it's amazing the tools we have. But I'm also kind of feeling like the Hubble is starting to be seen a little bit as like, okay, that was last generation smartphone. Let's chuck it and get rid of it and move on to the. And I don't know, maybe I'm wrong, but I just kind of almost felt like from Wisconsin, I could hear you from Arizona, Brenda, crying, no, don't. It's still an amazing thing to use for science. So I just thought we need to talk about this to give Hubble its due, which is why I'm calling this conversation Hubble is our space telescope in trouble. A little riffing on Shakespeare, but we'll have a common conversation. So with that, Brenda, I was just wondering if first you could just, in case people are not aware of you, who are you, where are you from, how'd you get into science, and then we'll just kind of start from there and start talking about the Hubble and how you view it fitting into the current astronomy landscape of research science.
That sounds wonderful. Yeah. Okay. My name is Brenda Frye. I'm a professor of astronomy at the University of Arizona. I got my PhD at University of California at Berkeley in astrophysics, and from there moved on to the East Coast to take a couple of postdoc appointments at Princeton University. And then I took my first teaching professorship in Ireland, actually, for 6 years. And
Nice.
from there, moved to California before getting recruited back to the University of Arizona. And because, in fact, this university is also my alma mater. So it's where I earned also my bachelor's degree in physics and in astronomy. But
Nice.
enough of that. Glad to be back. Never thought I'd be back so many years later. So it's a nice way to come home, circle back.
Now, I just have
So
to
as for
ask,
how,
with
yeah,
St. Patrick's
yeah.
Day coming up, was Ireland simply professional, or was there some cultural, uh, you know, in, cultural influence on why Ireland? Or
I guess it turned out to be just strictly professional. So when you're a scientist, it's very hard to decide which city exactly you're going to live in, and much easier to fill out the job applications around the country or around the world, and then move where you get the job offer. So that was our first job offer, my husband and I, in Dublin, Ireland. So we jumped at it. You
Nice.
know,
So
so how did I get into science? Oh yeah, go ahead.
I was just gonna say it wasn't about corned beef and cabbage then, so
Yeah. Not so much, although we ate so much porridge that when I finally moved back to California, I think I didn't eat it for 5 years after that. It really
Hi, even though you're
uh,
not Irish, you know what the Irish look like. You just
well, I have, some Irish background the way a lot of us do in this country, I thought I had an Irish name, Brenda, and yet when I first moved there, went to the bank, to start up an account, as we all, have to do when we move to a new place. Um, the representative looked up at me and said, "Don't you just hate your name?"
oh gosh.
I don't know. I guess it's okay. I don't know. Maybe. And she said, "My name is Brenda too." And I think if you're from Ireland, you see maybe Brenda as a feminized name of a masculine person. It was Saint
Interesting.
Brendan, who was the great explorer, and they kind of just dropped the N and said, "Okay, that's for women." So
That's
perhaps that was why.
fascinating.
But for us, we don't have that
I was gonna
association
say
at all. So you
I
never heard of it.
never would have even been on my radar screen, so
We see, yeah.
yeah,
Anyway, so and for me, it's just been my name, so that's fine.
yeah.
But and yeah, you do affect a small accent some of the time after you with them for a while, so that they understand you better, even more than you're understanding them. But
Reminds me, Jim Gaffigan in his comedy routines, one time he talked about how he was in Ireland. He couldn't figure out about this great American musician that everybody asked him if he liked their music of Billy Joel, and like, "Who's Billy Joel?" And I'm just like, "Yeah, Billy Joel, Piano Man," you know? And I'm just like, "Oh, Billy Joel."
finally get it. Yeah, that's right. Yeah, yeah. That's a very good point. Yeah,
Yeah,
music is a big part of life there for sure.
mhm.
Um, but as for getting into science, I suppose there's a couple of things. One is in high school, as a junior in high school, I had my first job as an intern um, at Pepsi Cola Company, in fact, in Phoenix,
Oh,
Arizona, in summer when it gets very, very hot, as you can imagine. So when a Pepsi machine breaks down, then they expect it to be repaired really quickly. So they call us and we help to dispatch a repair person. We help talk them through it and keep a database and all that. So I enjoyed the first 4 days. And then I learned my job by that point, how to run the database, how to talk to people on the phone, how to calm them down while you get help, and so on. And then I looked around and I saw other people there who worked there for years. And I realized I learned my job in 4 days, but I really want to find a job that will take longer than 4 days in order to master it,
yeah,
just for me. So I
yeah.
wanted a job that might take my whole life in order to truly feel like I had a complete understanding of the field. So I felt if I went into science, then I would come into work always having to learn something
Nice.
new. And why astronomy? Well, I think I went one time with my friends to the public library and we said, we're just going to take questions and dreams we always had, and we're going to look up the relevant books and we're going to read them and come back next week and talk to each other and do it again and figure out what we want to do. And I came across a book, I think it was White Dwarfs, Black Holes, and Neutron Stars. And I thought when I read the book that what I read was fact, but it was stranger than any fiction I could imagine in my mind at that point. So I decided that I had to learn more of that, and that
Yeah.
led the way to astronomy.
And thank you for starting with that, Brenda, because in a real way, what you just shared is one of the reasons why I love your presentation so much. I think that so much in our world today, not just with science, but with a lot of different things, if we don't understand something, it intimidates us and we start to, pull back and get a little bit of fearful of, well, I can't understand it. So I'm just going to disengage and let somebody brilliant like you take care of it. And I'll just kind of sit in the background but, regardless of where we're at in terms of intelligence and that kind of stuff, or even within faith, the unknown shouldn't scare us. The unknown should motivate us. It should give us that sense, and that's why for me, as a priest, I've always been inspired by your presentations in terms of if a parishioner gives me a good question to answer and that kind of stuff, and I don't quite know what the answer is right away, not to panic and fear and think that somehow my faith is in crisis, but that just that constant process of, oh, great, I've got something new to discover. I've got something new to understand that, I don't have a perfect understanding of God, believe that or not, that I too can grow. And I think that that's something that, and you don't have to comment on this. I mean, I'm just kind of going off on it as a priest. Feel free to if you want, but I just feel that one of the biggest things that people of faith, not just Catholics, but any denomination or Muslim or Hindu or so, is that science can teach all of us that when you find something you don't understand, embrace it, don't fear it, dive into it. And I remember the first time when he said the dark energy and dark matter kind of constitutes roughly 98% of the universe. So we don't know what that is. We can see its effects, but we're not 100. I'm like, okay, if I were a scientist, this is the field I want to get into because similar to what you just said, I like engaging that unknown. So thank you for starting there. So I appreciate that. So
No, no, absolutely, and I appreciate you're also extending that lesson in the broader sense as well, because there are so many different ways in which we can try. And I have to teach myself every day as well at work. I have someone come in with a question I don't know, and I can suddenly think, oh, I don't know anything. Oh, I don't know what to do. And you really even now I have to calm myself down and say, well, we got through something like this before,
yeah.
and you're right, and it helps a lot. If we can find one place, one part of life in which we can apply that, then we can be able to use that lesson for all the other parts of our life, just as you're saying in faith as well. Yeah.
As you were talking about that, it reminded me when I was a high school teacher, and we were talking about. I was teaching sacraments, and I was telling them we were doing a lesson on grace and how grace is important. We need to understand grace, and at the same time, by the end of it, I was a little embarrassed because one of my freshman high school kids raised their hand and like, "How would you define grace?" And I was like, I've been using this word the entire class, but the kid's right. I haven't given them, and so I'm like, well, here's what the textbook says. But as a priest and someone who's pretty well educated in theology, that's really inadequate to really give the full expanse of what grace is. And so we actually ended up spending the rest of that period trying to, one, obviously just learn the textbook definition, but also to realize, understand how that doesn't quite answer all of it and how we can deepen that. And I think that that's why I miss teaching high school because those kids would always come up with those thumper questions that I just don't think of because at this level, a couple master's degrees in theology and that kind of stuff, there's certain things I don't even think about and process anymore, but they just kind of get you to thud in a healthy way to stop, wait a second, you need to clarify that. And it's like, they're right, I do. So, anywho,
Absolutely. Yeah. Yeah.
yeah. So from that standpoint, then, so I love that you started working for Pepsi, by the way. I just have this image of, hot Arizona working for Pepsi, and it's like, can I just drink my business all afternoon and just try to cool down? And then but then that now from working at Pepsi, journeys, got married, professional, explorations into science. How did you end up working on a team that gets time on the Hubble Space Telescope? How did that come about?
Yeah, well, it's a really good question. I mean, I had been working with Hubble Space Telescope data for quite a while before I started writing my own proposals, but at the time, the Hubble Space Telescope was the most sort of desired telescope in the whole world, so it felt like a pretty high bar to try to
Yeah.
reach. But as they say with the lottery, you can't win if you don't play. So,
Yep.
um,
I like that
so
analogy. So how has
you
your
know,
life changed since winning the lottery? Yeah, just like
yeah,
that.
right, exactly, yeah, Um, yeah, so I suppose what happened was it was really just the science motivation. So we came across some really enigmatic sources which emit really, really strongly in essentially at sort of microwaves colors. So the I guess your actual microwave oven uses a kind of radio type of waves in order to cook the food, called microwaves. These microwaves are, a little bit shorter wavelength than that, but still in that part of the spectrum. So it's a very sort of unintuitive color for most people to think of a microwave. But these were some of the brightest microwave sources in the entire sky. Or could look at the sky tens of degrees in any direction. We found 12 of these that were ultra bright and couldn't really figure out what they were. And we had to look at them at colors that were closer to the ones that we see with our own eyes.
Mhm.
So I felt we had pretty good motivation there to write this Hubble Space Telescope proposal. Tried a couple of times and didn't quite get through. And then I think the third time they gave the nod, and I felt very lucky indeed.
Nice. And so and I don't know if you know the exact numbers, but just kind of ballpark, how many so basically what you're explaining is your group submits a proposal. This is what we want to look for, and then there's a board that kind of reviews it and says, "Yep, it's worthwhile to have time," or "Nope, it doesn't." How many groups are vying for time on the Hubble ballpark? Would you presume?
All right. Well, I mean, I should have probably have these numbers more
Oh no,
more
no,
at
that's
hand.
fine. And don't feel like you have to speak in precise. This is a
Oh
conversation.
no, it's
This
okay.
isn't
No, it's
a.
okay. Well, I can just say that for every 10 proposals written, there's one that tends to get through. So it's about at that level.
Yeah.
And indeed, yeah, you send the proposal in, and that doesn't mean if you're chosen, you use the telescope the next day. You send it in, and then the NASA people at the headquarters, which are held at the Space Telescope Science Institute in Baltimore, Maryland, then call an international group of scientists to get together, especially for the larger proposals that comprise of about, it can be 8 to 10 people each from around the world. A number of us have served in these committees in the past and the present, and we typically, when it's not a pandemic year, fly into Baltimore and sit around the table and talk about these proposals so that every proposal gets a fair shot. The proposals are written dual anonymously, which means that we have to leave our names off of them when we send them in, and they don't get to see our names when they review the proposal either. And after this sort of international vetting process, the very best ones are selected, and those are the ones that move forward. And then even then, it takes months more planning for us to help write the script that helps to move the HST telescope, that helps determine which filters, which type of calibrations to take, and so on. And then eventually we get the data, and those are very exciting times.
Absolutely, yeah, and I could also imagine that would feel quite devastating to be rejected if you put all that work into. I mean, I just have a little, you know, someone called a toy, but the closest thing that I have is just kind of like a little. Oh, my little background is making it disappear, but I just have a little astro camera that I just kind of. I mean, I know how difficult these things can be. Of okay, do I use H alpha or O3 or S2 tonight? Man, putting together a proposal like that, I mean, that is, I mean, next level doesn't do it justice in terms of using that kind of analogy. I mean,
It takes a bit of effort, and you
yeah,
said you're worried about rejection. Well, you'll almost always be rejected, right? With that kind of acceptance rate of 1 in 10.
yeah,
But it is a huge amount of work to do in advance. That's why I always thought if I was ever an administrator anywhere near that level, that I would do something like lobby to send every person who got rejected at least a free coupon, for a cookie or something. you know,
come on,
so
just
because they could put the coupon on their door that at least shows that they applied, because even just
exactly.
that, yeah, it deserves a kind of a honorary medal or something.
And actually, I think there is a. But I love that idea because I remember I got involved in a citizen science program about 7 years ago with Panstar on supernova hunting, and it was really fun. I lucked out and I got in right at the beginning of the whole thing, and they just said, look through these pictures, identify potential supernova candidates, and if you're one of the first three people to submit, will put your name on this as a contributor to this. And so, man, I just blitzed through tons of it, and I ended up with 3 candidates. They were never confirmed, and they warned us about that up front, that, that there's so much data now on supernovae that if there's it might be wrong to call any supernovae garden variety, but if it's one that it's clearly they already have data on, they're probably not gonna go through the process of confirming it. But the ones that are unique, the ones that look a little bit different, they will. So, but I still was able to say it. I would contribute to a potential supernova. So I like that kind of a
Very
little
nice. Yeah.
congratulations for submitting a proposal. And cookies would be nice, oatmeal raisin or chocolate or something.
Well, yeah, yeah, you could cash it in and get your
Yeah,
cookie, or as a ritual,
yeah.
or you could put it on the door or something, or yeah, right.
The Hubble cookie, I like that. Just kind of that's awesome. So, yeah, so you get time. Now, you mentioned these, magnetic phenomena that you really couldn't that you made the proposal of. So you got the time, so what did you learn about it? What did you discover through that unknown proposal that was accepted?
Yeah,
Or are
but
you
really
still
really
working on
hoping. Yeah, yeah. Oh, well, I
it?
am, yeah, but the Hubble Space Telescope portion is now complete
Mhm.
anyway, and then I recently got time on the James Webb Space Telescope as
Good.
well to observe this same object, which might be the subject of another
Yeah.
conversation. But for for the Hubble Space Telescope, yeah, I guess we learned that these objects were so blindingly bright at this particular wavelength because not because they're just intrinsically blindingly bright, but because they are gravitationally lensed. So indeed, this comes back to um, this research interest of mine to try to follow up on Einstein's idea that really massive objects bend the light around them.
Mhm.
So this was really just yet another test of that theory. And we thought that that might be the case, and that's partly why I was, interested in this particular problem anyway. But it wasn't until we got the Hubble Space Telescope images that we could really see that. And that's because the Hubble Space Telescope is above the atmosphere, so it enables far more crisp pictures and images of objects than you could ever get from the ground. There's some specialized cases now in which you could get observations from the ground at really high spatial resolution and get really crisp
Mhm.
views, sharp views of the universe. But it's still far better just to get them, and much more efficient just to get them from space. So it's when we got those really high resolution images, like getting that new, digital camera or something that has that
Yeah.
factor of 10 improvement in spatial resolution. You almost wonder if you didn't have the right prescription of glasses at first or something like
Right.
that, because
Mhm.
something that was fuzzy now suddenly all comes into focus. And we saw a lot of beautiful evidence of a lot of really distinct galaxies that would normally look round but got distorted into banana like shapes
Mhm.
instead, by optical illusion of gravitational lensing. And it was in seeing those arcs, as we call them, that we were able to verify um, that these were, what these were, that these were sources that were lensed by this massive object in
Mhm.
between us. Yeah.
Yeah.
So that was the main discovery.
I was thinking about you the day that that first public image of James Webb Telescope dropped, because when I looked at it, just from your presentations, I was like, "Oh, there's a sign of gravitational lensing." And so I started to, all right, does this one look like this one? And is this one, are these two the same that are being reflected out because of lensing and all that kind of stuff?
That is the funniest thing because that's exactly what happened. So none of us knew what those first public data sets would be, not even the astronomers.
Hmm.
And yet everyone in the public was given them, right? So any small child, any grandparent, anyone in between, anyone could just download that actual data set. But we didn't know what it would be, not even the astronomers. So we were supposed to be delivered this information on July 12th of 2022, but instead we hear something also that President Biden wanted to deliver some of the data, or at least the initial results, on the night before. Okay, so we show up in time, and I think on some tweet it was told that astronomers everywhere are bobbing their heads in unison to the metronome of elevator music because they were about an hour late in order to start this press conference. It's like it's supposed to be at 5 and it started at 6 or something. None of us were gonna eat dinner, of course, because
Of
we're
course.
astronomers. We have to just sit there glued to the screen. So we're just bobbing our heads waiting
Kinda
for the
like me
staff
at a
on time.
Packer game, I don't wanna go to the bathroom, I might miss a touchdown, I'm just kind of like,
Right.
I'm just like
Exactly right. Except for this dear image of this lady in the corner who's sitting there just like this for the entire time, and I thought, "That takes a lot of control," but I think she was she 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 was meant to be helping those who are hearing impaired, with sign
Oh,
language, and she had nothing to do either for the whole hour, but she had to sit there with her image there.
mhm.
Anyway, finally, they delivered this image, and like you said, even though it was very far away, I don't know if you remember, it was like
Yeah,
several feet away and everything. We could still just see it. And I just realized, wow, exactly as you say, that's a gravitational lens. I had no idea that it would be. I heard it would be galaxies, and I thought, well, 100 billion galaxies in the sky. So sounds good to me.
good
I'm sure it'll
chance
be
that that
fun.
might be,
You know, but then to think that it was actually centered right on exactly the type of object that I've studied, since I was a student, right up until the present day, his was really thrilling. I think there's a tear came down my eye, and I called some former undergraduates of mine. I like to work with really young students, are just starting to learn astronomy and everything. And I called them up and I said, "Let's do this thing." And they said, "When?" And I said, "Now."
wow.
So my husband said, "Sure, bring him over." So kind of did that. And 3.5 days later, we submitted the paper, which turned out to be the second fastest submission in the world using any James Webb Space Telescope data. So we just didn't stop. We just worked nonstop for those 3.5 days.
I should have pulled an all-nighter then. I could have I don't know what I would have been submitting. So but I don't no, but I just well, I'm very consoled to hear that that was your response because when I saw it, I'm like, "Oh, yeah, Brenda talked about this. This is exactly what she was presenting to us at Faith in Astronomy workshop." So, yeah.
Yeah, that's right. And in fact, I was lucky enough to start a gravitational lensing program for the James Webb Space Telescope on the invitation of um, someone, the PI of Pearl's principal investigator of a James Webb Space Telescope team, who had extra time and decided that he wanted to spend it by observing some of these gravitationally lensed fields. So you know, I helped him to select the team and get it all set up and so on. So it was because, and we have a team that spans 4 continents of the world. So we already had everyone in place who was going to observe James Webb Space Telescope data. So when these first public images came in, we were already in place all around the world. So that's how the project didn't have to sleep. It wasn't just me, but we would do our part and send it to the East Coast, or do their part and send it to Europe, and send it to the Middle East, and
Oh,
send it to Australia and Asia, and it circled around like that. So we were able to kind of work nonstop.
nice. Awesome. Well, then this might be a good point to transition then, because I don't know. The more you talk, maybe you do think of Hubble as like the outdated cell phone. Just crash it through the atmosphere, burn it up. We got the James Webb now.
No,
But
certainly not. Certainly
good,
not. In
good,
fact,
because I
in
still love the
fact, in
Hubble.
fact, In fact, the Hubble can look at colors that James Webb Space Telescope will never access, right? Essentially, the James Webb Space Telescope, even though we've seen beautiful images coming out of them, they're all what we might call false color, meaning that almost none of them are at the wavelengths, the colors that our eyes can see. So
Mhm.
the colors of the rainbow we see in the sky, right, that span all the colors that we can see with our own eyeballs, those are not largely are not detected by the James Webb Space Telescope at all. But all of those colors are we can take images in all those colors using the Hubble Space Telescope, and we
Yeah.
can even take images at ultraviolet wavelengths using the Hubble Space Telescope. And So we haven't a chance to do that with the James Webb, and all of that provides incredibly necessary information that helps teach us about what we are looking at when we look at those longer, redder wavelengths that we get from the James Webb Space Telescope.
Yeah. I figured that that would be one of the first things you'd bring up in terms of answering the question of how does Hubble fit into this? Because in a future conversation, I'm going to do a local conversation with, it sounds like it's disconnected, but I promise it is. I got involved with a citizen science program at Beaver Creek Reserve, which is a reserve here, and they do studies on saw-whet owls. Little tiny owls about can fit them in your hand. That they're not endangered, but they're threatened. And one of the things that they do to study these owls is they'll catch them at night, and I was there for it. And they'll turn off all the lights and have a black light, UV lighting, and they'll shine it on the feathers. And there's a I can't remember the name of the chemical that excretes from their wings, but it illumines in UV lighting, and from that they can tell how old the light or how old the owl is based on how this chemical illumines under UV lighting. And it was just fascinating to watch. And the first thing I thought of is like, oh, James Webb infrared telescope, being able to see, and so therefore to really, I mean, it's a horrible analogy, I'm sure, but this little saw it all, you got the visible spectrum that you can see, but there's part of it in the spectrum of UV that there's more information that you can learn from this little thing that you use UV for. And I was like, this is kind of similar to how different light spectrums and these different telescopes give us different information, and how different parts of that spectrum can deepen it, so it all kind of works together. It's not that one's better than the other. It's there's different kinds of data you can get from these different sources. So yeah, but
Yeah, that's exactly right. In fact, space telescope is smaller. The actual telescope is smaller. The mirror aperture is smaller. So you have to observe. The image that you get is not quite as deep for a certain exposure time.
yeah.
But the colors are very, very different, and that's especially useful when trying to study the distant universe,
Hmm.
for example, because we know what we know what the light from a single star would look like. For example, basically, if you take the light from a single star and put it through a prism, it does break up into a kind of rainbow of colors,
Hmm.
which we call a black body spectrum. It has a kind of peak wavelength, and it goes down on both sides. Our sun as well. You put the sun through a prism, and our sun you'll see a bunch of colors on one side, and it will peak, and a bunch of colors on the other side. And I can ask maybe, do you know which color might be at the peak for the sun? I'm trying to make it spectrum.
Well, it would definitely be the I believe it would be the red spectrum, mainly
No,
because
it'd be yellow. It'd
oh,
be
yellow.
yellow.
That's
Yeah,
sorry.
yeah, right. So we actually see the sun as yellow because it peaks in the yellow. Although it does also emit, our sun emits red, blue, green, all the others, right? We know that because when we put
Yeah,
sunlight through the prism of our own atmosphere and it makes a rainbow, that rainbow you
yeah.
see is telling us all the colors that are in the sun.
I'm sorry,
So
I overthought your question because I was like, "Okay, is this the H alpha she's talking about? Is this"
no, no,
yeah,
oh,
I'm
I
just
see,
kind of
yeah.
like
No, no, it's fine, no,
which light bands are we talking about? Like, yeah, just it's yellow, so it comes in
yeah,
yeah.
yeah, yeah, and there are green stars, blue stars, purple stars, red stars, all kinds of stars. Ours just happens to be yellow. But, a galaxy has a huge number of stars, right? Enormous number of stars, maybe, 10 billion stars on average. And so you need to take all of those different rainbows and put them together. And some people try to imagine what that looks like and give us a kind of composite of summing all those up, saying what
Mhm.
they look like. And then when we take that spectrum and we kind of ask, how would we take that one, prism spectrum of a galaxy and move it way to the distant universe? Whenever we do that, we see, aha, so the colors that are brightest now come at the wavelengths of which you observe the James Webb Space Telescope. So that's where the peak wavelengths are. That's not a surprise. That's part of why we built the James Webb Space Telescope.
Yeah.
Well, not me, but those who did. at those wavelengths to try to observe the most distant sources. But there's also colors coming in at all the other
Mhm.
wavelengths have colors too, just like I said, including the ones that Hubble can have access to. And so we really need those, what we call actually bluer colors, the Hubble Space Telescope has access to, so that we can use them in order to help confirm what we think are discoveries of some of the really most distant objects. So it, in that sense, it plays a little more of a supporting role, but a really important supporting role that
Yeah.
it helps move the story along, just like a great supporting actor, would move the story along. So
And thank you for sharing that. I personally am really excited to, for me, I ordered, I mean, on the very beginner level, just some, different gratings, like a 50 grading, a 100 grading, to start to use my camera to collect spectra data, just to do really simple, looking at, how when that, the color when the prism effect happens, what's the chemical makeups of different stars and that kind of stuff. So it's even talking. I'm just like, oh, I can't wait for that grading to get here, and I hope I get some
that's exactly it.
so I
Yeah.
can start to play around with that. And obviously, it won't be anything approaching the kind of stuff that you do, but the core principles are there of taking a look at the different band passes in terms of where the absorption lines are and what can that can tell us about composition. And I just last night it was I mean, and again, for those of you watching, like I said, I'm a hobby astronomer. I'm not a professional, but I was watching a video on how to distinguish the simple way that you take a spectrum line and understand if the star is red shifted or blue shifted, and how when you line up the lines, well, if the lines don't match up anywhere, start moving it either to the red or the blue spectrum, to get the sense of where it might be shifted. And I'm like, oh, that's so basic and that's so simple, that's so understandable. And so I'm like, I'm actually going to be able to do science now with just this stuff. And anyway, just it's
Yeah, but astronomers had to suffer in that same way as well in the 1960s when we first discovered some distant objects in the universe,
mhm,
and we would take the spectrum of them. So we'd take the light from the object, put it through a prism, break it up into the colors, which, as you say, is called the spectrum, and we'd look at the different features in it and try to match them up. It's almost like matching up the UPC code. And
yeah,
once you
hmm,
register the UPC code, you'd
that's a
say, "Oh,
good way
that's
to put.
Frosted Flakes, not Cheerios," or something. Yeah, yeah. So it's like you're getting that UPC code. But then there were some objects that were so distant we couldn't recognize the code. We couldn't match it up with anything. And it's only just like you say when we really moved that pattern very far
To the extreme
into a different part
redshift.
of the spectrum. Yeah, into
Yeah.
extreme redshift that we were able to recognize it and realize we had just discovered some truly distant objects. So we, go through some of those same, growing pains.
Yeah. Well, I do want to respect your time. I'm just going to look here, and we've been talking for about 45 minutes. So I always like to keep these conversations under an hour, just first of all, to respect your time, but just also just to respect the viewers' time too. So maybe if you just want to end, it's, I know your group made the news a while back, about some discoveries you made, and you don't necessarily have to talk that. I mean, you're more than welcome to, but in light of that, I was just kind of curious, what are some of the discoveries your team has made with Hubble or with James Webb already that you're proudest about? The things that you're just like, wow, if I'm gonna give like the world a resume of these are the things that I really just I really feel personal satisfaction about with your work with this. What would those things be?
Well, I guess you caught me with good timing. Just yesterday, I submitted a new paper to the Astrophysical Journal as first author. One of the things I'm most proud of actually is that we involved 9 different students on the paper, which is extremely rare. There's usually you work with 1 or 2, but really there were 9 students, and they can come onto your program and tell you exactly what they did. They all contributed something meaningful, and I wrote it all up and made it all sound coherent and so on. And what we did is we analyzed James Webb Space Telescope data, which is the story of the hour, even though it's supposed to be Hubble Space Telescope. So sorry about that.
Oh, it's okay. It
But
still
the
matters. It
reason,
really does.
yeah, well, in fact, it does because the reason we know where to point the James Webb Space Telescope is because we're all observing with the Hubble Space Telescope, analyzing those data, and then when those results are interesting, we forward those as targets for the
Mhm.
James Webb Space Telescope. So again, it's a little bit of a supporting actor's role, but incredibly important. And that's how we knew where to point this James Webb Space Telescope for this particular object, which we call El Gordo, which means in Spanish the fat one, because it's one of the biggest, fattest clusters of galaxies in the whole universe. And what that means is a, again, a single galaxy, can have huge number of stars, 10 billion stars. And a galaxy cluster can have hundreds of those all orbiting each
Mhm.
other, like bees orbiting a beehive. And that acts as this gigantic mass that bends the light of anything around it. So that was the target. And what we discovered to our surprise was that we got such deep and beautiful imaging with the James Webb Space Telescope. They were able to detect not only just this massive El Gordo, but a kind of second large mass way in the distance behind it. Normally, as we are discussing, you might find one object or two objects in the distant universe, but now we're able to find whole groups of these galaxies that are just basically forming what we think will be clusters very far in the future. So now we're able to see how these baby metropolises get started
Oh.
and eventually grow to become the gigantic galaxy cities we call galaxy clusters in the future.
Mhm.
So that work we were just putting out this week, and we'll have an international press release in the next week or two. I'll let
Oh.
you know.
Well, I was gonna say you don't have to. I'm not gonna try to break anything on here. I want to protect the professional integrity of what you do. So even though I'm like, okay, I'm gonna read that as soon as it comes out just to see what's going on. But as kind of a way into it, one of the things that, in a weird way, is entertaining in probably an unhealthy way, but also annoys me is when I see all these clickbait things of like, James Webb has destroyed our understanding of the Big Bang Theory and all this other kind of stuff just to exactly. And I'm just like, there's a certain National Enquirer aspect to that where there it is kind of entertaining for a little bit to, okay, what kind of crazy thing are they going to say that's not true? But I was going to say that without revealing anything you're not ready to reveal yet about your research, but what would you say to people that are being fed this nonsense, to be quite frank, about
Oh, right,
uh,
right. About these ultra dramatic sort of pivots in our understanding of science in general. Yeah, there really aren't such things, and there aren't uh, scientists typically don't make huge leaps in very different directions. Okay, we tend to study what has been done in the past. We tend to move forward, by standing on the shoulders of others. And of course we want to make a big step forward. um, and as a scientist, I guess the most powerful card we can play is one that rules out a prevailing idea. It can take a long, long time to sort of confirm something you're quite sure. But if you can rule out certain parts, then it helps you, as especially as an observer, as I am, to move forward. But yeah, so it's rare and probably never that we would actually ourselves say, "Oh, we've completely turned Einstein onto its ears" or something like that.
right. Hmm.
Yeah, that's right. Yeah.
And that to me is kind of and I think that that's one of the things for me because when I first started getting into this, I might have, being that I'm not a trained scientist, I would have been very prone to fall for some of that, at the beginning of all this, just because of, the even within my own journey with this is like, science is never going to have a doctrine, they'll have a theory. But the theory is more than just a good idea. I mean, there's some, it may not be doctrinal. There might be, it reminds me, It reminds me a little bit more of what Cardinal Newman talked about of, in terms of his understanding of development of doctrine, that even within, like, for example, right now the bishops are kind of coming up with this big congress on the Eucharist, and it's going to happen in a couple of years. And one of the dangers I find in the faithful is, well, we have to teach them exactly what the Eucharist is. Okay, what is it? And then, well, I mean, you can get into the Augustinian, or excuse me, the Aquinas language of transubstantiation and coming together and forming the man. But that doesn't mean that that's the only language that can be used. That's the best language we have. And so much what you're just saying, that if we do find a deepening of the language of what is the Eucharist, it's not going to be, a complete 180 from what we understand, but it's going to be a new dimension, a new way of looking at it, a small piece to gain our understanding. And I think that that's the beautiful thing too, that I personally see, that's a nice connection between faith and science, is that even though you can have these huge moments of like technological leaps like James Webb, the development of truth there, it does kind of, it's slow. It takes time. It takes discernment. It takes peer reviews. It takes theologians to kind of take a look at new ideas and determine them, healthy or unhealthy and that kind of stuff. And so the tools might advance quickly, but how we process what those tools bring, if it's a slow process, it's probably the right one. And if we jump too quickly, we're heading for error in both realms pretty quickly. So,
Yeah, it's a very good point in both realms. It's an incredibly rich set of ideas
yeah,
to discuss that evolve over time,
yeah,
and we have a lot of a good future ahead of us.
exactly. And that probably is a good place for us to wrap up. So, Brenda, I could talk the day away from you, but I know that you've got a job, I've got a job, and so we got to kick back to what we're supposed to be doing. Is there anything about this whole idea of how do we understand these amazing astronomical tools we have before us, or our understanding of science, that you wanted to share that we haven't talked about yet before we wrap up?
Well, I think we've covered just about everything. I guess the main last topic to say is that science is in astronomy is really participatory.
Mhm.
Yes, we have a lot of jargon and there's a lot of math and physics in astronomy, but one can also get across quite a lot of concepts um, through discussion, and one can contribute to science as well through this kind of discussion. And all of us, whether we're astronomers or not, can share in these discoveries and potentially make a contribution. So do get involved with astronomy and do read up on the Hubble Space Telescope and the James Webb.
Great, thank you. And I do want to say one last thing to anybody who's watching. I did know the sun's yellow. I just misunderstood the question. I just sorry.
No, no,
I,
no. I shouldn't ask questions
Oh, no, no,
just
no,
because
that's
of
fine. I
it.
just, well, I'm throwing stuff at you. It's fair game to throw stuff back at me, so that's not a problem. Like, I'm not an ignoramus, I promise. So,
Oh no, no, I know. Yeah, I know. Yeah, of course.
no, but as always, Brenda, it's a delight to talk with you, and thank you for your time. And anybody who is watching this, either on Sacred Space, Astronomy, or Vatican Observatory Fanboy, I'll just kind of leave some links down below for some things that Brenda's worked on with Steward Observatory and that type of a thing. And of course, always feel to keep up with us on the blog for the Vatican Observatory Foundation. And our next conversation I'm going to have, and I kind of intuited it a little bit, is that completely different realm. We're going to talk about little owls, little suet owls, or sowet owls, and how the use of light, and then kind of to dovetail off of what we've talked about here on how different ways of approaching light can give us different understandings of things to deepen our understanding of a thing, whether it be the stars in the sky or whether something that's flying over our head. So, thank you for your time, Brenda, and I hope to talk to you again soon.
Thank you, thank you. It's great to talk to you as always. Take
Great.
care. Be well. Thanks.